So I'll go to Arish, who was asking whether SPD will suppress the current transient. If it won't suppress, then what will be the solution?
No, of course, it will suppress the current transients. So transient, the current flow, actually, it is because of a voltage. The voltage, depending upon the impedance of the line, it is inducing a current. So both are related, voltage and current, transient over voltage and the transient current are related. So SPD is the protection against the voltage. In fact, the current is diverted to the other lines. As a result, your equipment are safe.
Thank you. Sandil has put up 3 questions. Sandil Kumar Velamurugan. When we say S2 and S4 flash near to the structure and service, respectively, is there any distance limit defined to be considered?
Yes, of course, the distance limits are there, but at the moment I don't remember it, and referring the standard and giving an answer will be a little bit difficult. I will put this answer on the blog. Please look at the blog after 2 or 3 days.
Okay, Sandil Kumar, again, we are also hearing type 1+2 and type 2+3 SPD. Can you throw some light on those as well?
Actually, imagine a type 1 SPD. The same SPD can be tested for the type 2 current parameters as well, because for type 2, the current parameters are always lesser than type 1. A type 2 SPD always passes the current, the discharge current limits of type 1 SPD. And an SPD, if a type 1 SPD is also tested for the type 2 parameters, we can call it as a type 1+ SPD, 1+2 SPD. But you should find out what application you are using it and whether you require really type 1 or a type 2 for a sub-switch board, and you have to select that. Otherwise, this combined type 1+2, type 2+3, these are actually meaningless. You should look at what is the highest current. Type 1 is good, type 2 is good, type 3 is good. Okay. Also, nowadays, manufacturers are trying to give an information that a type 1, 2 SPD is an SPD which is internally coordinated with the next level of SPD. The coordination between the SPDs are also taken care in this case.
Okay, what is the difference between impulse withstand and impulse immunity?
Yeah, impulse withstand means an external impulse. Your device is able to withstand this impulse voltage. Basically, the impulse voltage in this case is between the lines, live conductors and the earth. Impulse immunity means your equipment is operating under certain conditions. Let's say, for example, you have a motor, and your motor is connected with 3-phase, and in case of any transient between the phases, whether your equipment is able to still run without any problem, or your equipment is very simple, immune to the transient or not. So these two are a little bit different. One is between line to earth, and the next one is between connected lines.
Okay, Ashok is asking, but I'm not going to understand his question. Why install the opened wire of high tension wire? Is there no other option? I don't know. Can't understand the question.
Oh, me too. I am also unable to understand the question.
Ashok ji, if you can rephrase the question and put it again, we'll take it up because we are unable to understand the question. So Senthil has many more questions. I'll keep that for a while I take Tara Dal, who is also a regular webinar attendee. Is it like this to protect SPD by fuse? Is it like this to protect SPD by fuse? I don't know. How can we ensure supply and protection together? Another.
Yes, this also has been replied. So both continuity to supply and protection can be ensured by providing SPDs with multiple discharge devices inbuilt.
Krutivanti and Narasimha Rao is asking, what is the typical life of SPD? Yeah,
normally, if your electrical installation is satisfying all the requirements of safety and reliability of the written in the standard, average you can expect about 15 to 20 years. But again, it depends where you are installing the SPD, and near to your SPD, what kind of switching equipments are present. Say, for example, near to the capacitor switching panel, probably the life is a little bit lesser, maybe 3 years or 4 years. But sometime near to in a place where there is no switching surges available, probably the life is 20 years. On an average, 15 to 20 years you can expect.
Sanil sir, I will come back to you for another 3 more questions that you asked. I'll just take a few more other questions, then I'll come back to you on this. Saravanan is asking, instead of fuse, can we not use MCCB for SPD?
Actually, this is the manufacturers are actually trying to interpret it in different ways. If you look at the catalog, most of the manufacturers are recommending GLGG fuse. Nobody has written to use an MCCB. But some manufacturers, say for example, some specific project clients are asking, can I use a 63 amps MCB? Of course, we have made the test and made the submitted the test reports, but that is very specific for a specific application. But the MCCBs are, I would say, a little bit difficult to answer. We have to really look at the manufacturer's catalog and test report. But to my knowledge, most of the manufacturers have tested the devices with the fuse, HRC fuse. You can have it, see it on their catalog.
Priya Brata Mohant is asking, what shall be the minimum length of line or cable beyond which more than one SPDs will be required at source or near equipment?
Yeah, the recommended length is about 10 meters. That means at the main switchboard, if you have an SPD, after 10 meters, you are supposed to have one more SPD, but practically this calculation has got a very difficult answer, because you cannot have so many SPDs in your network. But the solution is, if you go for the entire protective measures like equipotential bonding and all, like main protective equipotential bonding, supplementary equipotential bonding and all, then this length can be increased under certain conditions. It can be even 30-40 meters. Sometimes you don't need additional SPDs inside your building. It all depends on what kind of installation you are using, what kind of wiring methods you have followed, and what kind of shielding measures and cable routing measures you are carrying out.
I'll go to the 4th question of Sendil Kumar. Does any type of earthing system like TNS, TT, etc., mandate a particular type of SPD connection, that is CT1 and CT2?
Yes, there is one restriction. For example, in case of a TT system, if you are connecting an SPD before the RCD, then CT2, especially the 4th SPD between neutral and earth, must be a spar gap. So otherwise, the CT1, CT2 is really okay, but the TT network 3+1 connection is recommended for.
Okay, so we'll go to the 5th one. I think only you could read this very technical question that I could find. TOV defined for 5S and higher voltage, for example, 770 VAC TOV for 5S for an operating voltage of 230. Your opinion on this?
Yeah. I understood what he's asking. Is of course, again, this more up to 5 seconds, certain voltage can appear due to a high voltage fault. Up to 1200 volt is allowed, and your wiring and equipment are supposed to withstand that 1200 volt. That means 770 volt also can come up to 5 seconds, and SPD between connected to earth must be, especially in a TT network. This is applicable for a TT network. This stress is not applicable for a TN network. Between neutral and earth, this kind of a situation can come.
Pravat Kumar Sau is asking how to calculate or select the current rating for SPD for individual houses or office.
I have shown 3-4 slides. So the first question is whether your building have external lightning protection or not, whether your building have got overhead line or not, whether your transformer is closer to the building or not. Based on these questions, you can select. Now, If you have a low voltage supply line and the supply line is overhead coming from far away, then of course, irrespective of your building has got lightning protection or not, you need a type 1 SPD. If no lightning protection, no overhead line, then of course type 2 SPD. Transformer inside your building, again type 2 SPD. So 3-4 slides I explained. Of course,
Okay, Hans Slaughter.
are there. Due to time, I could not answer all the conditions. Sorry for that.
Okay, moving to Hans Slaughter question. What about MOV coordination of MOV device? Is the same switchboard such as RCBOC, which include MOVs within the same switchboard?
RCBOs which include MOVs? Oh, I don't know. I never heard of RCBOs with MOV. Probably there are some latest SPDs are there, which is an RCCB with an SPD. It is not inside RCBO, but there is a combination of SPD and MOVs, not MOV, SPD and RCBs are there. I don't know whether you are asking of that combination or otherwise RCBOs. I don't think that it contains an MOV. But of course, if it has got an MOV, then the RCBO will be having a parameter which is called as its voltage withstanding, impulse withstanding capacity, and the MOV which we are putting prior to the RCBO must reduce the voltage impulse to a lower level, a level lesser than its withstanding capacity. So by that, automatically we achieve the coordination.
Moving to Priyabrata Mohanty, what are the tests to verify healthiness of SPD?
Yeah, we have got an SPD tester, a handheld SPD tester. When we do the electrical safety audits or when we do the verifications of the lightning protection system or SPD, we used to test the SPD modules. We have to unplug the SPD and put it into the meter and find out whether it is healthy or not.
Okay. The Chandramohan Sachdeva is asking, under what circumstances SPD becomes hazardous and results in fire or blast?
The first is if the SPD itself is of very poor quality, especially something imported from our neighboring country and put a nice label and sell it in the market, very cheap but very dangerous. That is the point number one. But most of the time, the SPDs from China it will not blast because the SPDs from China, it contains only the casing. Inside there is nothing. So since there is no MOV or since there is no real discharge device except the outer casing, even if you put it, it won't blast because there is nothing inside. There is no real SPD. Number two, if there is an MOV inside, you have to be very careful. The second chance is if the backup fuse selection is not proper, again, the SPD and the combination can blast. Temporary overvoltages also is an issue.
So Ved Prakash is asking why we faced a flash at 11 kV VCB termination point even after SPD is there and SPD not blasted.
Actually, our subject is low voltage, whereas you have asked for the high voltage SPD, but of course not an issue. Most of the time, the high voltage SPDs are connected with long lead wires, especially from the surge arrestor to the earth electrode. 3, 4, 5, 6, 10 meters of wires are used. If you use a longer wire, of course, the effectiveness of the SPD is gone. SPD will not work. Your VCB will blast. There is an IS standard and the standard recommends to put to connect the SPD with a very, very short wire length. Please do that, then the problem can be solved.
Satish Shulan is asking, is there any maintenance requirement for or a periodic inspection and testing for SPDs? If yes, please explain the method or IEC standard number.
This IEC 62305 part 4 is explaining what to test and what to check. Of course, there are handheld devices, small test instruments available exclusive for testing the SPD, and you have to use that kind of an SPD tester and You have to test it. Since the question so many people asked, I will just show you how the SPD tester looks like. One moment, please. With the SPD tester, you can very easily check whether the SPD is healthy or not. You have to wait for a second. Yeah, one moment. I'm just sharing.
Okay.
So whatever you are seeing on the screen, this is an SPD tester. It is a device with which any kind of devices, SPDs or MOVs or GD tubes or silicon avalanche breakdown diodes can be tested. It actually put an impulse voltage into your equipment, and it tells you these either the spark over voltage or the voltage 1 milliamps protection level or the clamping level of your MOV. So these devices can be used for testing your SPD. But again, one more device which will be of interest is the just a second. The surge counters. Surge counters are devices with which you can measure the number of surges and its a time and date. For example, this is a surge counter. You can put it inside your panel board. So the surge counter, you can see the controller, the CT is on the earth wire, and it records the number and the date and the time of the surge. So these devices are quite useful. So over to you, Mr. Dominic. Next question.
Hans Lauter has come back again, rewording his question. What about MOV coordination of MOV device? Is the same switchboard such as RCBOs, which include MOVs within the same switchboard?
What about the MOV coordination of MOV devices in the same switchboard such as RCBOs, which include MOV? Mr. Hans, I'm not sure whether the RCBOs are having MOVs inside. I never heard that RCBOs are made with MOVs. In fact, I'm not an expert in RCBO. I know that RCBO will trip in case of any overcurrent or earth fault or earth leakage current, but MOVs, I'm not sure. But the very simple method to find out is if this device have got an MOV, the manufacturer should provide the effective impulse withstand voltage. Imagine the RCBO manufacturer says that his voltage impulse withstanding capacity is 2.5 kV. And if that voltage impulse is achieved by installing an MOV inside the RCBO, means the MOV is having a protection level of lesser than or equal to 2.5 kV, say for example. If you are using an MOV SPD in that switchboard, which is limiting the voltage to lesser than 1.5 kV, you don't need to worry about coordination because automatically coordination is achieved. If SPD is having a protection level higher than 2.5 kV, then only your coordination comes into picture. But as I said, I'm not sure whether RCBOs have an MOV or not. This is still an unanswered question for me.
Chandramohan Sachdev is asking, in case there is a mobile tower in the vicinity, do we still require SPD?
Of course, if you have a mobile tower in the vicinity, you must require SPD because once when the lightning strike the high voltage, or sorry, not the high voltage, the transmission tower of the telecom company, the ground potential rises, and there can be induced current through the earth connection of your house. In order to protect the electrical system, you must require an SPD. I know that in some cases in Kerala, a few years back, after installing during the initial days of telecom revolution, after putting the tower, all the neighbors' houses during lightning season, the electrical system started failing. Then finally, the company who has made the tower, they have installed SPDs free of cost to all the neighbors. So of course, this is required.
Suresh Kumar is asking, are there SPD are only for lightning protection or can be used for surges due to switches, switching off equipment, IGBTs and capacitors?
Any transient overvoltage means lightning is one. All the others like switching of equipment, switching of whatever the transients which is created within the system also can be limited by installing an SPD.
So Satish is asking if the electrical asset cost is less than 5 times the cost of SPD, then it is not economical to install SPDs. Does this mention in IEC 60364 or any other document?
Yes, of course, it is from the standard. I just copied those wordings from the standard.
Okay. So we have 3 more questions. Prasad is asking, transformer is very near to building. Line to ground fault at 11 kV. I think this is a high voltage. Should we take this high voltage question, sir?
Yeah, one moment. The line to ground fault 11 kV of the transformer due to. Okay, see, transformer is very close to the building, and 11 kV ground fault due to squirrel in between some animals went into the 11 kV, the live part and the earth. As a result, 2 motherboards of the lift burned. But interesting is no electrical and electronic gadgets were damaged in the fault. No SPD is provided in the apartment. How do we interpret the same to damage occurred or gadgets in the flat? Actually, this was a subject which we discussed last time. I explained a case study of the lift. The lift is supposed to have a voltage impulse category 3. The lift is a part of a fixed installation. It is of installation category 3, means the minimum impulse withstand voltage is 4 kV. But most of the lifts which is sold in India, I am doubtful whether these tests are really carried out and the certificates are provided. I tried with several manufacturers. They always offer that next week they will give me show me the certificate, but still the next week has not come. But now here the problem is whenever there is the lift has got the earthing like a TT system, and in a TT system, whenever there is a high voltage fault, and if the high voltage side and the neutral of the secondary side of the transformer are interconnected, the voltage of the fault is transferred to your LV system, and your equipment at the LV can fail. In fact, we have made a blog last week in this subject. I will just try to find out the blog, and I can post it in the exclusively on lift. I can post it in the chat box so that you can have a look. Yeah, this is not in a blog, but the subject has been posted in the LinkedIn. I'm just putting the link. So if you click the link, you will be able to see the reasons for this particular problem. So the next question is Mr. Senthil Kumar.
Senthil Kumar again, is the surge counter communicable?
Yes, of course, you can connect it to your BMS system.
So last question from Mohammed Sharif. Is it suggested that SPD can be connected to MDB branch breaker, or SPD cables are connected parallel with incoming cable of MDB?
Oh no, the incoming and the outgoing cable. That means at some point in your line, you are connecting an SPD. The incoming and the outgoing lines, that is the line before the SPD and after the SPD, must be segregated. Otherwise, the protection cannot be achieved.
With this, I think we have completed the full questions. Unlike last time, we kept some questions are pending. But still, if you still have any questions that is unanswered, or you still have any doubt, you can please communicate. We have mentioned Mr. Gopakumar's email ID and also the blog that is available, all these previous recording of the webinar, and also the website of Mr. Gopakumar. So please feel free. And also in the beginning, we showed that Mr. Gopakumar is a specialist in very interesting product line of various such protection. We'll share that to all the participants about the very specific product and technical specification of the product through email. So also, ladies and gentlemen, I would like to inform you that we will be doing, if you are in Bangalore, we will be doing a physical seminar on 9th September at 7 o'clock. So it will be a combination of a speaker and panelist. So we have well-known architect, electrical consultant, and the end user participant, and the fire department also will be participating. If you're in Bangalore, or if you're in and around Bangalore, we'll be happy to send you invitation. If you want an invitation, please write to Ms. Lakshmi, whose mail ID also mentioned down there in the chat box, and we will be happy to receive you at the venue. So thank you very much. You all have a wonderful weekend. Look forward to see you again in our next webinar, which will be informing you shortly. Thank you, Mr. Gopakumar, for your valuable time and wonderful presentation. Always you're in demand, and every presentation that we make, there's a lot of learning and a lot of knowledge that has been shared. Thank you so much.